Hello friend. Now today we will discuss about this fixed point iteration method, or it is called the iteration method. Now this fixed point iteration method, it is useful for finding the real root of the equation. Obviously it may be algebraic equation or the transcendental equation. Now see what is this fixed point. If suppose we have the equation f(x) equal to 0, and if we express this equation f(x) equal to 0 in the language of x equal to function of x. See what is this fixed point. If suppose we have the equation f(x) equal to 0, and if we express this equation in the language of x equal to 5x, that means this input of the function, this is same as the output of the function, then this point x, this is called the fixed point. See what is the definition of fixed point. If suppose we have the equation f(x) equal to 0, and if we express this function f(x) equal to 0 in the language of x equal to phi of x, that is input of the function, it is same as the output of the function, then this point x, it is called the fixed point of that function. Now suppose if we consider the function f(x) equal to x square minus 2. Now let us find out the fixed point for this function x square minus 2. Now x equal to 2, this is the fixed point for this function, because if you put x equal to 2, then what is the value of this f2? Put x equal to 2, 4 minus 2, that is 2. So what is this equation? Input of the function, it is same as the output of the function. X equal to f of x. That means this x equal to 2, this is called the fixed point for this function. Also this x equal to minus 1, this is again the fixed point for this function. Now if you put x equal to minus 1 in this function, then what is the value of f of minus 1? Minus 1 square, it is 1. 1 minus 2, it is again minus 1. So input of the function, that is same as the output of the function. So obviously this x equal to minus 1, this is the fixed point for this function. So for f(x) equal to x square minus 2, we have two fixed points, x equal to 2 and x equal to minus 1. Now if we consider suppose the identity function f(x) equal to x, then for identity function there are infinitely many fixed points, because if you put suppose x equal to 0, then what is the value of f0? It is again 0. Put x equal to 1, then what is the value of f1? It is again 1. If you put suppose x equal to 2, then what is f2? f2, it is again 2. So input, it is same as the output. So this is again the fixed point for this function. So remember this, for identity function there are infinitely many fixed points. So first of all, remember the definition of fixed point. What is the definition? If suppose we have the function f(x) equal to 0, and if we express this function in the form of x equal to 5x, then this point x, this is called the fixed point for that function. Now this is the working rule for the fixed point iteration method. Now see what is the working rule for the iteration method. If suppose we have the equation f(x) equal to 0, it may be algebraic equation or the transcendental equation. Suppose it is given. Then what is the first step in iteration method? Express this function f(x) equal to 0 in the language of x equal to 5. This is the first step. What is the working rule for this iteration method? If fx equal to 0, if suppose that is the given equation, then what is the first step? Express this equation fx equal to 0 in the language of x equal to 5x. Where what is second step? The size of this derivative, it should be less than 1. What is the second condition? It is the sufficient condition. Modulus of phi dash x, it is less than 1. Size of this derivative, it is less than 1. If these two conditions are satisfied, then we can apply this fixed point iteration method. These are the necessary conditions for the applicability for the fixed point iteration method. So what are those conditions? First of all, express the given function fx equal to 0 in this language, x equal to 5x. What is the second condition? Size of this derivative phi dash x, it should be less than 1. Then and then we can use this iteration method. So let us consider one example by which we can easily understand what is this fixed point iteration method. Now this is the example which is based on fixed point iteration method. Now see what is this example. Find out the real root of the equation x cube plus x minus 5 equal to 0 by using fixed point iteration method. Now see what is the working rule for the iteration method. This is the working rule. If suppose we have given some equation, suppose it may be algebraic equation or it may be transcendental equation, suppose. Now fx equal to 0, that is suppose the given equation. Now this is the given equation, x cube plus x minus 5 equal to 0. Now what is the first step in iteration method? Okay, first of all, express this equation fx equal to 0 in the language of x equal to 5x. This is the first step. Now what is the second step? This size of this derivative phi dash x, modulus of phi dash x, it should be less than 1. Then according to working rule, there exists a sequence of approximations. Then according to our working rule, there exists a sequence of approximations. Suppose xn is equal to phi of xn minus 1, which converges to a fixed point, and that fixed point, that is the real root of this equation. Now see what is this working rule. If suppose we have the equation fx equal to 0, then what is the first step? We have to convert this equation in this language, x equal to 5x. What is the second step? We have to check this condition, the modulus of phi dash x, whether it is less than 1 or greater than 1. If it is less than 1, then and then we can apply this fixed point iteration method. If this derivative, if it is greater than 1, that means we cannot apply this iteration method. So according to this working rule, there exists a sequence of approximation. This is suppose that approximation xn equal to phi of xn minus 1, which converges to a fixed point, and that will be a real root of this equation. So what is this approximation? If you put suppose n equal to 1, suppose, then what is x1? The first iteration, it is given by x1 equal to, put n equal to 0, so this is phi of x0. So it gives the first iteration. If you put suppose n equal to 2, then what is x2? x2 will be phi of x1. Put x equal to 3, x3 will be phi of x2, and so on. What is the last iteration? Phi of xn, this is equal to phi of xn minus 1. So this is the sequence of approximation, suppose. So according to this rule, there exists some sequence of approximation. This is that approximation which converges to a fixed point, and that will be a real root of this equation. Now the question is, Is there any unique way to express this form x equal to phi of x? What is the question? If suppose we have given some fx equal to 0, we are given some equation, then is there any unique way to express this equation in this form x equal to phi of x? So the answer is no. We can express this equation in number of ways. We can express this equation in different way to reduce this equation in the form x equal to phi of x. So let us write down the solution. So this is the given function. Let fx equal to x cube plus x minus phi. So what is the first step for finding the real root of the equation? Just substitute the values for x equal to suppose 0, 1, 2, 3 and so on, and get some opposite functional value. This is the step number 1. How to find out the real root? Just replace some real values and get some opposite functional values. Now suppose if you put x equal to 0, then this is 0 plus 0 minus 5. So minus 5, this is the negative functional value. Put x equal to 1, 1 plus 1 it is 2, 2 minus 5, this is minus 3, this is again the negative functional value. Put x equal to 2, 2 cube it is 8, plus 2 10, 10 minus 5, so this is positive functional value. So we know this concept that always the root lies between the negative and positive functional values. So see, what is the first step? Just substitute the values for x, just put the different values and get some opposite functional value. So obviously the root, it lies between 1 and 2. So right here, therefore the root lies between 1 and 2. So we can take the initial root x0 as in between 1 and 2. So we can take 1.5, we can take x0 equal to 1.75, we can take any value in between 1 and 2. Now see, how to apply this fixed point iteration method? What is the working rule? First of all, express this equation fx equal to 0 in the language of x equal to phi of x. This is the step number 1. What is step number 1? Just express the given equation in the language of x equal to phi of x. And just now we have said that there are different ways to express this equation in this language. Now see, this is one of the form. This is the given equation. Suppose x cube plus x minus 5, this is equal to 0. Now from this equation we have to find out the value of x. We have to express this equation in the language of x equal to phi x. That means from the given equation we have to find out the value of this x. Now what is this value for x? X equal to 5 minus x cube. So this is our function x equal to phi x, where what is the value of phi x? Phi x equal to 5 minus x cube. Now just now we have written that the root lies between 1 and 2. So we can take any approximate root. Let us take suppose 1.5. Now if you put suppose the initial root 1.5, then 5 minus 1.5 bracket cube. Now what is this value? This will be 1.625. Now find out the next approximate root. Put x equal to suppose 1.625. Put x equal to 1.625. So this is 5 minus 1.625 bracket cube. So what is this value? This is nothing but 0.70898. Find out the next approximation phi of 0.70898. So this value will be 5.0 35637. Now what is our observation? If we consider this expression, suppose x equal to phi of x. See, we are given some function fx equal to 0. Then what is the first step? We have to express this equation in this language, x equal to phi of x. Now this is one of the way to express this equation to this form. Now if we take the values in between 1 and 2, let us put suppose x equal to 1.5, then we get this sequence of approximation. Now if we observe these roots, now this is 1.625, this is 0.75, this is 5.35 and so on. So these roots cannot converge to unique point. This will be divergent. So this root cannot converge to unique point. That means we cannot use this expression. Now there is also another way to find out whether this function phi it is applicable or not. Now what is that method? Just find out the derivative of this phi. Now what is this derivative of phi? Phi is 5 minus x cube. So what is the derivative? Derivative will be minus 3x square. Now if you put the values in between 1 and 2, then obviously, suppose if you put x equal to 1.5 suppose, then obviously this value, this should be greater than 1. For all x which is belongs to this open interval, suppose 1 and 2. We have to substitute the values in between 1 and 2. Now if you put the values of x in between 1 and 2, then we observe that this derivative phi dash x, it is greater than 1. That means we cannot use this iteration method for this function. So this function does not work. So let us try for the another function. So let us consider this function. So write down now x cube plus x minus phi equal to 0. Then what is the value of x cube? X cube will be 5 minus x. Then what is the value for x? X will be 5 minus x bracket raised to 1 upon 3. So this is one of the way, or this is the different way, or this is the second way for writing this function fx equal to 0 in the language of x equal to phi of x. So right here, that is x equal to function of x, where what is phi x? Phi x will be 5 minus x bracket raised to 1 upon 3. So see, this is the first step. What is the first step for the iteration method? Express the given function fx equal to 0 in the language of x equal to 5. Now secondly, what is our verification? Just verify this condition whether phi dash x, the size of this derivative, whether it is less than 1 or not. If size of this derivative, if it is less than 1, then and then we can use this iteration method. So find out the derivative. So write down now modulus of phi dash x is equal to modulus. Now what is this derivative? This is 1 upon 3 5 minus x raised to 1 upon 3 minus 1. So this is minus 2 by 3. So this is equal to modulus 1 upon 3. This is 1 upon 5 minus x bracket raised to 2 by 3. Now if you put the values of x in between 1 and 2, put any value for x which is in between 1 and 2, then what is our observation? This derivative, this is always less than 1. So this function satisfied both the conditions. So see what are the conditions for the applicability of iteration method. First of all, express the given function in the language of x equal to 5. This is the step number 1. What is step number 2? This size of this derivative, it should be less than 1. Then and then we can use this iteration method. So right here, therefore, this fixed point iteration method, it is applicable. So write down the first approximate root. So write down therefore first approximation, this is given by the formula x1 is equal to phi of x0. So first of all, take the initial approximation x0. So write down the initial approximation first of all. So right here, let x0, suppose it is the initial approximation. So we can take in between 1 and 2. So let us choose 1.5. We can take any value in between 1 and 2. We can take 1.75. We can take 1.65. So let us put x0 equal to 1.5. So find out the first approximation x1, that is given by the formula phi of x0. So this is phi of, put x0 equal to 1.5. So this is, now use this function phi x, put x equal to 1.5 in this function. So this is 5 minus 1.5 bracket is to 1 upon 3. So what is this value? This is given by 1.5183. Now find out the second approximation. Which is suppose x2. Second approximation, it is given by phi of x1. Put the value for x1, it is 1.5183. So use the same function. So this value, this is given by 1.5156. This is the second value, 1.5156. Now find out the third approximation x3. This is given by phi of x2. Put this value for x2, it is 1.5156. So this is given by 1.5160. Find out the fourth approximation x4. That is suppose phi of x3. Put this value for x3, it is 1.5160. So we observe that this is again the same value, 1.5160. So what is our observation? Third root, it is 1.5160. This is the fourth approximate root, which is again same, 1.5160. So up to 4 decimal place, it is same. So we can say that this is the real root of equation. So write down here the conclusion. Therefore, the real root of equation is 1.5160. So remember this method, that is the fixed point iteration method. So what is the rule for applicability for the iteration method? What is the first rule? Okay, first of all, express the given equation in the language of x equal to phi x. This is step number 1. What is the step number 2? Verify the condition the size of this derivative, it should be less than 1. Then and then we can use this fixed point iteration method. So thank you for watching.